Yelp is a local search service powered by a crowdsourced review form that helps businesses gauge both how they are doing from the customer's viewpoint as well as engagement and growth. As a platform based on consumer reviews and ratings, it can help drive traffic to or away from businesses. For that reason, positive reviews have become a crucial goal to local businesses. Sounds simple enough, but the larger Yelp grew, the more it faced issues of overwhelming its user base with the sheer number of reviews and details listed on a business's page, making it harder for the user to find the specific information they were seeking. It also faced issues like how to order reviews, how to address fake reviews, and how to best provide easily digestible summaries for their users. Through our project, we're working towards minimizing the potential risk of a local business losing a sale just because there was too much information to sift through by converting qualitative information into quantitative format. One of the issues with the current Yelp platform is that sometimes the aggregate rating of a business conflicts with the reviews that are directly below, meaning that a business might show a combined rating of 2 stars but have raving positive reviews directly below. When this happens, the user loses trust in the accuracy and validity of the review. In today's culture, headlines have brought more and more awareness to the manipulation tactics sometimes employed online, like fake Amazon reviews in order to make a product seem more legitimate. Another issue has to do with the Yelp review filter that exists today. The filter's purpose is to recommend reviews which it determines accurately portray the products or services of the business, and hide the reviews it determines do not. The filter also removes reviews that are flagged as spam by its users. Super helpful for ridding of most fake reviews, however, it runs the risk of hiding authentic positive reviews due to it not knowing much about the reviewer. Because the algorithm associates lack of information about the author with higher potential of the review being fake, it sometimes weeds out authentic reviews. And when these reviews describe positive interactions, the businesses tend to feel slighted by Yelp. Due to this lack of information, existing literature depicts developing programs which aim to accurately determine how reviews affect the demand and revenue of businesses, and others that are working on extracting subtopics from reviews to determine what customers care about. None of the above approaches, however, address the problem of producing numeric results for the actual content within the reviews, and therefore do not offer an easier to digest solution for users. This solution could potentially help the users as well as the businesses by providing more accurate summaries. Lastly, the previously mentioned filter and other developing programs that aim to accurately determine how reviews affect the demand and revenue of businesses don't do anything to help with the cognitive overload issue. So that is where we chose to focus. Using machine learning, we sought to turn qualitative review content into quantitative scores with the logic that leveraging numerical summaries would make digesting more reviews easier and faster. This would deplete the opportunity for manipulation, or pinning reviews to the top, and increase the accurate portrayal of a business's customer experience. So we began with our Yelp reviews dataset. We took the first 1,000 reviews and performed a train test split, 75% train, 25% test. And with those sets, we passed that to a sentiment intensity analyzer as one of the means for extracting features for our model. This analyzer outputs 4 different values: a positivity, a neutrality, a negativity, and an overall sentiment value. We then trained our model with the training set, and then we tested our model with the test set, which output an accuracy score. We conducted 2 experiments in our study, one to identify the correlation between the number of reviews passed to a model and the ability of the model to accurately predict ratings, and another to identify text feature extraction methods which produce the highest prediction accuracy and lowest mean square error of our model. One of our interesting findings was that having more features was not always best. In fact, our best mean squared error came from a pairing of only 2 features, word polarity and sentiment analysis. Another one of our findings was also unexpected. Our model experienced some pretty significant overfitting as we increased the number of reviews we passed to it. This is most likely due to the variability of the review content in our dataset. We also found that increasing the number of reviews we ran through the model didn't increase accuracy. This could be due to one of 2 things. Either analogous ratings had similar review content, or reviews of the same rating had vastly different content. Although we didn't see a significant increase in our accuracy, we did see an improvement in our mean squared error. As we passed more reviews to our model became more precise, even though it did not necessarily become substantially more accurate. We do believe that future research should be done in better identifying the correlation between a review's content and the rating that it's given. This will help services like Yelp quantitatively summarize their reviews, resulting in better usability of their platform and more accurate aggregate ratings for the businesses.